Have you ever wondered what it might be like for an entire world to be a volcano? While this would not be all that hospitable to us, or any life form for that matter, it certainly would make a pretty cool movie setting. And as it turns out, we have one such world right here in our cosmic backyard, the solar system. For this, we look no further than our largest neighboring planet, Jupiter, and its moon, Io. Io is the most volcanically active place in the solar system. In fact, Io's volcanoes are so abundant that they renew the surface of the moon faster than comets and asteroids can pepper it with craters. These volcanoes are also sometimes powerful enough to be seen from Earth using large telescopes. I find Io interesting in the Jovian system because unlike its neighboring moons, it has no water or ice to speak of. Why is it so different when they are all orbiting the same planet? The answer to this lies in tidal forces. These come from a combination of Jupiter and two of Io's fellow largest moons, Europa and Ganymede. These two moons perturb Io's orbit into an abnormally elliptical shape. This means that Io experiences a wide range of varying distances from Jupiter, which are what generates such strong tidal forces. These forces stretch Io a lot. In fact, they can cause its surface to bulge up to 330 feet. For a point of comparison, Earth's highest tides bulge by about 60 feet, and that's with water, not a solid crust like Io. Now, out of the 4 Galilean moons, Io orbits the closest to Jupiter, sitting right around 262,000 miles away from it. This is close enough that during parts of its orbit, it will cut across Jupiter's magnetic field lines. This in effect turns Io into a giant electric generator, capable of developing 400,000 volts across itself, creating an electric current of 3 million amperes. This current then takes the path of least resistance right on back to the surface of Jupiter, creating lightning in its upper atmosphere. Let's have a look at some of the known volcanoes on Io. In this picture, taken by New Horizons in 2007, we can see a huge volcanic eruption in the form of a plume, which came from its Vashtar volcano. This eruption was 180 miles high, simply massive. For a quick comparison, the 2022 eruption in Hunga Tunga Hunga Hapai reached up to 36 miles, though it did have more gravity from Earth competing against it. Here, we can see Io's largest volcano, or probably more appropriately called a volcanic depression, Loki Patera. This depression is 126 miles in diameter and contains an active lava lake. Not somewhere that I would want to go swimming, that's for sure. Lava lakes such as this one are partially filled with molten lava, which is directly connected to a magma source below, and a thin solidified crust often exists on top of the lake. This crust over time will cool and thicken enough to not be buoyant over the lava. This leads to episodic eruptions of Loki Patera, which can disperse the crust over about 0.6 miles a day. This cycle repeats itself, which is why I've called it episodic. I am fascinated with the fact that we have such a volcanically active moon right here in our solar system, and I hope that in the future it can help us to learn and understand a little bit more about just how tidal forces operate and affect both moons and planets, and just how exactly all that heat moves itself from the core up to the surface. For now, though, we can continue to enjoy stunning views and data brought to us by existing spacecraft. I hope you've learned something, and I implore you to step outside tonight and look towards the stars.